Welcome to the StudyOrgo edition of the explanation of an E1 reaction mechanism. In this reaction, a haloalkane with a good leaving group, such as bromine, is reacted with a weak nucleophile and a weak base, such as methanol, to form an alkene product. The alpha proton is located next to the carbon with the leaving group. In this reaction, the bonds between the alpha carbon and the proton, as well as the bromine and the carbon, will be broken, and the electron density will be donated to the two carbons to make the double bond. Let's take a look at the reaction mechanism. An E1 reaction mechanism is said to be stepwise, meaning that there are two steps to the reaction. In the first step, the carbon-bromine bond spontaneously breaks to form an unstable intermediate called a carbocation. Carbocations, because of their instability, are only observed with tertiary carbon centers. This is because tertiary carbon centers give the carbocation stability through the process of inductive effects. Inductive effects donate electrons to the carbocation center between the carbon-carbon bonds of the tertiary center. This allows for the carbocation to be stable enough to react in the second step. In the second step, the weak nucleophile methanol will abstract a proton from the alpha carbon, donating the electrons from the carbon-hydrogen bond now to the carbon-carbon bond and neutralizing the carbocation intermediate. This generates the alkene final product. To further drive the reaction, the bromine anion leaving group will attack the methanol, which is an oxonium ion, and donate the electrons back to the oxygen, reforming methanol as a weak nucleophile for a second round of reaction. We at StudyOrgo like to give you the tips and tricks to help you predict the reaction mechanism for the individual reactions you will encounter on the exam. However, the large number of variables makes this difficult for us to explain, so we have efficiently organized the variables into a convenient table to help you study. By clicking on the Additional Materials tab in the Study Charts link, you will see the E1 and E2 comparison chart. The E1 and E2 reactions, as well as the SN1 and S2 reactions, are organized on the top, and the variables you will need to consider are located on the left. Let's take a look at the first variable. Kinetics refers to the rate order of the reaction. In this case, E1 stands for first order, meaning that only the concentration of the reactant is important. This is because the intermediate that's formed, carbocation, does not depend on the nucleophile. Remember that for an E1 reaction mechanism, it is said to be stepwise. That is, there are two steps, the first being formation of the carbocation, and the second being nucleophilic attack by the weak nucleophile. The solvent for an E1 reaction needs to be polar protic, meaning that the solvent has ionizable protons to donate. This helps to stabilize the leaving group and the carbocation in solution. In this case, the nucleophile is also the solvent, methanol. For an E1 reaction, the substrate has to be tertiary. It is impossible for a primary and very unlikely for a secondary carbon to provide enough inductive effects to stabilize the carbocation. Remember that without the carbocation, the reaction cannot proceed. Good leaving groups are always required for E1 reaction. Tosyl groups, as well as halides, are always a good choice. The nucleophile for E1 reaction is usually weak. If the reaction encounters a strong nucleophile, the E2 reaction mechanism will take over. The chemistry of the reactant is unimportant due to the mechanism of formation of the carbocation, because nucleophilic attack is not required for E1 reaction mechanism. Many complex molecules have more than one alpha carbon next to the leaving group that could react via an E1 elimination. So which one do you choose? In our example with methanol, the elimination will produce a Zaitsev product, meaning that the double bond exists between the carbons with the most substitution, or said differently, the more substituted product will be observed. Something that always happens with carbocation formation and in the E1 reaction mechanism is rearrangement. In complex molecules, if there is a next-door neighbor carbon that has the possibility to form a more stable carbocation, for instance, if the original carbocation is secondary and the next-door neighbor carbon could be tertiary, then hydrogen shifts, methyl shifts, or ring expansions will be observed to form the more stable carbocation. Remember, the most stable carbocation always wins the reaction. Finally, increasing the temperature is always an efficient way to increase energy of the reactants to overcome the transition state intermediates that will lead to the final product. That concludes our explanation for the E1 mechanism. We thank you for watching.